Okay, good afternoon, everybody. So in the last lecture, we were talking about implementing our own string type. And so we came up with this little structure here that represents our string, right? So our structure has three members in it. The first is the length, so that's the length of the string. The second would be the capacity, and so that's the length of the array that we have to store characters of the string. Right? Our capacity is always going to be at least one greater than the length, so that we can store the null terminator in our array. And then finally, data is a pointer to the first element of our array that will hold the characters of our string. Data will always be dynamically allocated. So in the previous lecture, I showed you how to use this, just the structure on its own. And so people who use the structure on their own would have to deal with setting all of the values of the members of the structure every time they manipulate a string. Instead of doing that, it makes more sense, if you're going to go ahead and implement a string type, to also provide functions that operate on the structure. And so that's what we're going to do today. The notebook has the full implementation of the QString type. I'm going to do what you're not supposed to do. I'm going to try to do this live. So let's see what happens here. All right, so if we look at the header file, we've got some functions here that basically deal with initializing a new QString object. Right? So these functions, sort of like constructors do in Java. Right? They're responsible for creating a new QString, right, and initializing the state of the QString. So the first such function here is called new, or QString new, right? And it allocates a QString structure, and it sets that QString so that it's the empty string. Right, so in other words, its data array contains a zero, a null terminator in it. So that would be like a no argument constructor in Java, right? So the string no argument constructor makes a new string that is the empty string. QString from CString creates a new QString object and initializes it by copying the characters from a standard C string, right? So that's S. Right, so again, that looks a lot like a constructor. Right? In this case, you're constructing a QString given a C-style string. And a third one, QString copy, lets you, again, create a new QString object, this time copying the contents of another QString object. And so these three functions here, they all are similar to constructors in Java. And so, not surprisingly, they're all going to do something very similar. So let's go ahead and try to implement these things. Well, first, before we implement them, let's see what you have to do to implement them. And so here are the three functions in our, so I'm calling this QString underscore live as opposed to QString.c. So QString.c has the actual implementation in it. You have access to it if you have the course notes, right? You can just look in the notebook too, that's also there. So to implement new, so new is the one that makes an empty QString object. You're going to follow the following steps. Right, so this needs to return a pointer to a newly allocated QString object. So we're going to dynamically allocate a QString object. Right? When we do that, we're also going to dynamically allocate its array. Right? So remember, every QString has a data array that stores the characters of the string. Right? So we're going to initialize its data array to some default length. Again, we're going to dynamically allocate that array. We're going to set the length of the QString. So here we'll set it to 0. We'll set the capacity of the QString. So however big we make this array, right, we'll set the capacity of that array. Okay, so for QString from CString, so this is the function that copies, that makes a QString given a C-style string. We're going to perform more or less the exact same steps, right? So we're going to do this all over again, right, with some slight changes. Oops, sorry. Right, so we're still going to allocate a new QString object. Right? Now when we allocate our array, oh, I guess I shouldn't have called this S. SDR. Like that. Okay. Boom, boom, boom. Okay, now when we allocate our array, right, we're not going to allocate it so that it has some default length. We're going to make it so that it has the length of S plus 1. Right? So allocate of length. Oh, sorry. String length s plus 1. String len. There we go. Right. So however long s is, right, that's how many characters we need to store, and we need one more for the null terminator. Right. Of course, we're going to set the length to whatever string length that is. Right. And we'll set the capacity to whatever we need. We also need to do something else here, though. Right. I guess we also need to copy the characters from s into our Q string. Right. So I guess we can do that anywhere. I guess we'll do it at the end, but it doesn't matter where we do it, as long as we do it after step 2. Right. So copy characters from s into string data, like that. Right. And finally, the third function is more or less the same as the second function, except this time, instead of copying s, we're going to copy s data. So we're going to do all of this again. Allocate of length. So here we can use s dot length, s length. Right, so we can choose to do that. We could also instead allocate an array of s capacity. Right, so I think we'll do that instead. Right, either one's going to work, right? Because I know that assuming I do all of my work correctly, the capacity of s is big enough to hold the characters of the string plus 1. Here I can set the length to whatever s length is. Right, set the capacity and then copy the characters from s data into string data. Right. So all three functions do more or less the same thing. Right, and so whenever you're in the situation where a function does more, where you have multiple functions that do more or less the same thing, right, you're probably going to write one function and use that one function to do everything. Right, and so what we want to do here is we want to look at these three functions and try to extract the commonality out of them. Right, and the common part here is this one doesn't do any copying. So this step 5 here, we're probably not going to put into a separate function. Right? But everything else, steps 1 through 4, they all do more or less the same thing. Right? And so we can factor out that commonality and put it into a separate function, which is what I'm going to do first. Right? So I'm going to write a function that allocates a new string, right? A new QString object. So QString, I guess we'll call it alloc or something like that. Right? And so when we allocate the string, we want to specify how much capacity should the allocated string have. Right, so we're going to do something like the following. Right, and so after I've written this function, steps 1 through 4, I can just implement by calling QString alloc. Right, and that takes care of doing steps 1 through 4 for me. Okay, so let's do steps 1 through 4. So I want to allocate a new QString structure. So that's easy, right? So struct QString star. I guess we'll just call it S. No, let's call it str. Okay, so we want to allocate memory for a QString structure. So call malloc or calloc, whatever you want. I'm going to use malloc. So I want size of struct QString, like that. Right. So there's my allocate the structure. If you are following the rule that you should always check the pointer returned by malloc, then you want to check the pointer returned by malloc. So let's do that just to be complete, I guess. Right. Remember again that in Linux, this test isn't going to matter. Right. The malloc will never returns null. Right. So if not string, right. I know that malloc has failed. I should do something. Right. So the something that you do here, there's no standard way in C to indicate that an error has occurred. Right? This is one of the problems with programming in C. Right? C doesn't have any exception handling. C does not have any exception mechanism. So you can't throw an exception. So that's no good. Right? So what can you do? So here it's up to you what you are going to decide to do. Right? So remember, if malloc fails, It means that the operating system wasn't able to give you enough memory. So in this case, you probably can't do anything. Right? So here you want to probably print some error message if you can, and then exit the program. Right? Print some error message, maybe? Maybe. Right? The reason I say maybe is that printing some error message, I don't know how print is or how fprint is implemented. It might need memory, right? And so if fprint needs memory and I'm out of memory, I can't even print the error message. So I'm going to leave that unimplemented, but I am going to exit the program here. So like that. Right? So there's not much I can do in this case. Right? Again, right, in Linux and in Mac OS, right, this is, you'll never end up in here. Right? Malloc always never returns null. Okay, so I've allocated my QString structure. Now what do I want to do? I want to allocate the array belonging to the structure. Right? I want to allocate the array so that it has that much capacity. Right? So how do you do that? So the array is an array of char. Right? So char, I'm just going to call it buff, short for buffer. It's a string. So our QString objects always have a null terminator at the end. Right? In other words, they have the numeric 0 at the end. So instead of calling malloc here, I'm going to use calloc. Calloc writes zeros into the array. So if I write zeros into the array, I don't have to, in some cases, I won't have to remember to write the null terminator in myself. Right. So here I'm going to use calloc. Again, it doesn't matter. You could use malloc, right? You just have to remember that if you use malloc, you have to be careful of the null terminator. Right. So the way you use calloc is number of characters that you want to allocate. So here I want capacity characters. Right. How much room or how much memory does each element require? Well, each element is a char. So I can do size of char, which I know is 1, right? That's what the language defines. Right? Again, if you're going to be careful about, if you want to test if your allocation has succeeded, right? You're going to look at the returned pointer and test if it's null, right? So here, if buff is null, right? I've got there's an error. I couldn't get enough memory, right? So I'm going to exit again. However, before you do this, right, if you got to this point here, you successfully allocated. So the previous malloc succeeded. Right? So you could consider here, right, freeing str. Right? It doesn't actually matter in this case because all we're doing is exiting. Right? As soon as you exit the program, whatever memory your program is using will be deallocated anyway. But here I'm just going to be careful, I guess, about what I'm doing, right? And I'm going to remember, hey, I successfully allocated a buffer here, or sorry, some memory here. I should free it now that I no longer need it. Okay, if we get to this stage here, we've got our structure, we've got our data array. All I have to do is set the length and capacity. Right? So, I also have to assign buff to our QString. So it's QString data equals buff. Right, string length is 0, right? And our capacity is whatever capacity was passed in by the caller. Almost correct, right? We get one little bug here, right? The one bug is if the caller or whoever is using alloc passes in 0 for the capacity. Right, and so if you remember from our discussions of malloc and calloc, right, you should avoid allocating an array or a chunk of memory of size 0. Right? If you do, the return pointer is not usable for anything. And so here, I'm going to actually test for that. And so I'm going to do that before I try to allocate the data array. Right? So if the capacity is 0, right, I'm just going to set the capacity to 1. Right? And so that prevents this zero memory allocation bug that you can run into. Right? The nice thing about allocating an array of size 1 is that this is guaranteed to be the empty string, right? After you call calloc, right? You're going to have one character; its value is going to be 0, which is the empty string. So that's nice. Okay, so there's our allocation function. So now, inside of our constructor-like functions, I can just use the allocation function. Oops, sorry, structs QString star str. So now I can just call QString alloc. Right. For new, I want to make a new string, and I have to pick some default length. So if you go back and look at the header file, there is a constant static. This should be const, I guess. But there's a constant here that's defined as our default capacity. So it looks like our default capacity is 8. So I'm just going to use that. Right. So there's my newly allocated string, QString. Right. Not only is the structure allocated, its data array has been allocated. Right. Its length has been set, and its capacity has been set. So I can just return str here, and I'm done. Right. All right. If you're going to do, if you're going to copy, initialize a new QString object from a C-style string, well, we're going to do the exact same thing. Right. Steps 1 through 4 are taken care of by alloc, so I might as well just do this like that. Right. Instead of asking for an array of size 8, right, I want to ask for an array of that size there. Right. I also need to set the length to the length of s. So at this point, it makes sense to actually figure out what the length of s is. Right. So size t, string length s, like that. Right. When I allocate the QString, I want its capacity to be length plus 1, at least. Right. You could make it bigger. Right. I'm just going to make it the exact size that I need. Right. Once I've done that, I have to copy. So that takes care of steps 1, 2, 3, and 4. Right. Step 5, copy the characters from S into string data. So here you have several choices now. Right. So you need to copy a string into an array of car, which is a string. So you could use any of the standard library functions that do this. Right. You could use string copy. You could use sprintf. You could use memcopy if you wanted to. Right. All of them will work here. I'm just going to use string copy. Right. So if you remember how string copy works, it's destination followed by the source. Right. So where do I want to copy the string into? I'd like to copy it into str data. Right. Where am I copying the string from? I'm copying it from S. Right. After I've copied the string, what do I need to do? I'm almost done. Here, oops, step 3. So I guess our allocation function doesn't set the length, right? It sets it to 0. After I've copied the string, I now have a non-zero length string. So I guess I should set the length of the string here. Right. So QString length equals length. Right. From back here. Capacity was set properly by alloc. So it looks like I don't have to do anything else. Right. I've copied the string. I've set its length. Its capacity is set correctly. I can just return, sorry, what am I doing here? There. I can just return str now at this point. Like that. Right? And copying a QString is going to be exactly like copying a C-style string, only where you're copying it from is different. Right? You're not copying the string s, you're now copying the data buffer of the other QString object. So, copy this code here, plunk it down here. Okay, for the length, I don't actually need to compute the length, right? The other QString knows how long it is, so I can just write s length, like that. Right? I can then go ahead and allocate the QString object so that it has sufficient capacity. Right? I can then copy s data, right? So copy s's data array into str's data array. Right. Set the length of str, so that's whatever the length of s is, right? And then just return str, right? And there's your third function that initializes a QString object. Right. Any questions there? No? All right. So let's go back to the header file and see what else we have to implement. So there's new, there's from C string, there's copy, clear. So clear says it clears the specified Q string setting its length to 0, right? Returns S. Returns a null pointer if S is null. Oh, I guess I should take care of these. So returns an empty Q string if S is null, so that's nice. Okay, so let's go back and fix those up. All right, so this one, if S is null, this says that this function should return a new empty Q string. So if S is null, that's going to barf, right? String length of S will barf. You can't take the string length of a null. You can't call string length passing in null, right? So I guess I have to test if S is null first, right? So if not S, right, it wants me to return a new Q string object, right? So I can just do return Q string alloc, right? And you can make this however long you want. So I'm just going to return that. Right. So that's an empty string having capacity 8, right? So it can store a string of length 7 in it, right? But it is the empty string. Right. Similarly here, it says the same thing. So if the passed-in pointer is null, return a new empty Q string. So I can also just copy this code here, right? And take care of that requirement as well. All right, what about, clear. So clears a Q string. Returns a null pointer if S is null, right? So implementing this is straightforward, right? It wants us to clear the string, so setting its length to 0, right? Now, when you set the length to 0, you don't actually need to do anything to its data array. Well, sorry, that's not exactly true. There's one thing you should do to its data array, right? So, okay, so it says if S is null, return null, I think is what it says. Yes, returns null if S is null. Okay, so if not S, return null. Okay, so again, notice that in C, there's no one way to handle errors, right? If you have preconditions on your inputs, right? Here, one of the preconditions that S should not be null, right? There's no standard way to handle these sorts of errors. No exceptions, so I can't throw an exception, right? And so here, I've chosen to exploit the return value, right? The return value is a pointer of some kind, right? And I can use a null pointer to indicate that something has gone wrong, right? So that's how I'm indicating errors here, right? There are other alternatives. In this case, I think the simplest thing to do is to return null. Okay, so what do you do to clear the string? Well, you set its length to 0, so that's pretty easy, right? I can do that, right? I don't change its capacity here, right? Remember, the capacity is how long is the array belonging to S, right? So here I'm not changing the capacity. I don't need to fiddle with that. But I should go into the array and make that string the empty string, right? So in other words, I should go into data, right, and make sure that data represents the empty string, right? And so in C, the empty string is the string where the first character in the array is the null terminator. Right? So set the first character in the string to be the null terminator, right? And that's that takes care of that. Okay, so what does this return? It returns null pointer. It returns S, right? So it returns the Q string object that was passed into it to begin with. So return S there, right? Returning the Q string object that was passed into it lets you call another Q string function right away, right? So you can now nest function calls. And so the standard library does that a lot as well. Many of its string functions return a pointer of some kind so that you can call another standard library string function, passing in the return value from a previous function. Okay, so the methods that we're the functions that we're implementing now, these are all basic. These all would correspond to accessor methods in Java, right? So these are all functions that return information about a Q string. They don't modify the state of the Q string. Oh, sorry, clear, I guess, modifies the state. Okay, so in C, array access is unchecked, right? You can use whatever index you want, except for negative indexes, when you have an array, right? If you go past the end of the array, C says you get undefined behavior, right? But it will let you index past the end of the array, right? So here, if I want to get a character out of the string, so here I'm going to return a pointer to a character in the string, right? I have to decide whether or not is this going to be checked or unchecked access, right? If you're going through the trouble of implementing a proper string data type, you're probably going to you probably want checked access on the string, right? In other words, you want to check, is this index valid or not, right? Which you would normally do in Java or Python, right? In C, it's up to the implementer as to whether or not they're providing checked or unchecked access. Often what you'll see is that there will be two separate functions, right? So there'll be a get, and there'll be something else that does the same thing, except one of the two functions will be unchecked, right? And the other one will be checked, right? The reason why C programmers tend to do that is because C programmers don't like to pay the price of anything if they don't have to, right? And so, in other words, many C programs will argue, look, I'm going to call the function ensuring that I always use a valid index. Why do I have to pay for the test? Why do I have to pay to test if the index is valid, if I know it's already valid? Right. Java and Python are more pessimistic, right? So they assume that the programmer might make errors, and that's why access is checked. Right. So this one says, returns a null pointer if the index is valid. So this is checked access. So we're going to implement that. So we have to pass in a QString object in which to do. So we're going to return the character at this index, right, in this QString object here, right? Because we're only returning a pointer to a character, we're not actually modifying anything belonging to this object, and so we're marking this pointer as being const, right? We promise not to change the state of S. All right, so let's see, how do we implement this thing here? Returns a pointer, yada, yada, yada. Returns a null pointer if S is null. Okay. So like all of our other functions, if S is null, we're going to return null. So that's our way of indicating an error has occurred. Or that's our way of indicating that get was called, improperly called. Okay, we're also going to check the index now. So, yes, let's go back to the comment. Okay, so here it says the index must satisfy this inequality, right? So in other words, index can't be negative. It has to be less than the length of the string, right? You don't have to test that part of the inequality, right? Because index is of type size t, and size t is unsigned, right? There are no negative values that index can take on, right? Because size t is an unsigned type, right? So its smallest value is 0 anyway. So I don't have to check that, but I do have to check that. Right? So if, sorry. Oh, drat, sorry. If, okay, so if the index is greater than or equal to the length of the string. Right? That's a problem. Sorry, so is my spelling, sorry. So if the index is greater than or equal to the length of the string, well, that character doesn't exist, so I'm also going to return null. Okay, so if you get past this point now, everything's easy, right? I want to return a pointer to the character at that index of our string, right? And so what is a pointer to the character at that index of the string, right? So one way to write it would be the following. So sData index is the character at that index, right? If I want a pointer, I can just take the address of that character, and that would be fine, right? If you want to use pointer notation, return s index plus, sData. Ooh, Sorry, I can't, I have a hard time typing on these laptop keyboards because I'm used to typing on a full-size keyboard. All right, so if you want to use pointer notation instead, right? Remember sData is the name of the array belonging to our structure, right? So in other words, it's synonymous to a pointer to the first element of that array, right? If you have a pointer and you add an integer value to it, right? That's like taking a pointer to the element at that index, right? Which is exactly what I want. So these two lines are equivalent, right? However you write it, it doesn't matter. They both do the same thing. And so there's your get method, right? We have so we check whether or not the passed-in object is null, right? We check to make sure the index is valid, and if the index is valid, we go ahead and return a pointer to that character in the string. Right? So remember in C, when you return a pointer to a character, right, you can then pass that pointer to any function that takes in a string. Right? So you now process part of a QString using one of the standard library string functions. Okay, so there's get. Here's set. Right? Set is would be changing a character in a string. Right? So here we're going to change the character at that index to C. Right? Set is exactly the same as get. Right? You're going to do all the same steps, right? And then before you return the pointer, you're going to set the character at that pointer to C instead. Right, so we can just copy this out here. Okay, so the only extra thing I need to do is I need to set whatever character that is pointing at to C. So using array notation, you would write that, right? If you wanted to use pointer notation, so here you wouldn't want to use pointer notation because you have to dereference the pointer, right? But if you wanted to, it would be star S data plus index. So you could also write that, right? They're both equivalent in this case. Right, and they're set. So notice that this, so far, this thing is not terribly difficult to implement, right? There's another thing you should realize, right? So a string is basically a list of characters. So if you can implement an array-based string, you can implement an array-based list in C as well, right? They're the exact same thing. Okay, what else do we have here? Assign. Oh, yes. So assign, and so remember, so all of our the way that we're going to make people use our QString type is that they're always working with pointers to QString objects, right? They're not working with plain old QString structs, right? So they're always working with pointers to stuff, right? If you're always working with pointers to stuff, you can assign a pointer to a pointer. That's fine, right? But this doesn't let you assign a QString to a QString, right? So in other words, if I have some QString pointer S, right, and I want to copy or I want to assign to S to an existing QString the contents of another existing QString, right? There's no way for me to write that. So that's what QString assign is for, right? It lets me assign the contents of an existing QString to another existing QString, right? So this assigns the contents of the right-hand side to the object pointed at by the left-hand side pointer here, right? Here, LHS and RHS must both be non-null, right? They both must point at QString objects. What does this do if LHS returns is unchanged if right-hand side is null? Okay, so we should remember to do that as well. Okay, so if the right-hand side is null and the left-hand side is not null, we do nothing, right? What does this return? Returns LHS. Okay. So LHS remains unchanged if RHS is null, returns a null pointer if LHS is null. All right, so if RHS, if not RHS, right? So if RHS is null, we're always going to return whatever LHS is, even if LHS is null. Okay, so, oh, sorry, what do we do? Yes, that's right, return LHS. Okay. Okay, if LHS is null, then we're going to return null. So in other words, we're going to return LHS. Sorry. All right, so if we get past those two if statements, we know that we have two existing QString objects, right? One called LHS, one called RHS. I want to assign the contents of RHS to LHS, right? Now I have a problem, right? So the potential problem that I have is that the array belonging to LHS may not be big enough to hold the string represented by RHS, right? So in this function here, I need to make sure that that data array is big enough to hold the contents of this string here, right? And this is true of several of the other functions in this type as well, right? So here's concat, right? So concat concatenates the contents of RHS onto the end of LHS, right? Again, right? So if I'm joining two strings together, storing the result in LHS, I have to make sure that LHS has enough room in its array to hold the concatenated contents. Right, so there's another example of a function that might have to check whether or not the QString object has enough room in it to store a result. If it doesn't have enough room, what are we going to do? Right, we're going to reallocate the data array belonging to LHS so that it's big enough to hold the contents. Right, so here we're going to use realloc now. What else do we have? And then finally we have, okay, so that's good. So we have two functions that need to make sure our QString object has enough room in its array. Right? If there isn't enough room in the array, we have to reallocate the array. Right? And so because we have more than one function that needs to do this test, right, it makes sense to create a separate function that will do the reallocation for us if we need to. So that's what I'm going to do. That's what I'm going to do next. Right? So before I do any of this, right, I need to insert a function that will reallocate a data array for us so that it has so that it's large enough. Okay, so let's see how I did this. I'm just going to go grab it from here. So rather than type it all out for you, I'm going to show you what I did in the original source code. Right. So our function QString ensure capacity is the function that makes sure that that QString object there has at least that much capacity there. Right? If it doesn't, it's going to reallocate the array belonging to S so that it's at least that big there. Right? So how do you implement this function? Right? So you look at the capacity of S. Right? If it's already big enough, right, you're done. So you just return S. Right? Okay, so if that if statement is not true, right, then I know that I have to reallocate S's data array. Right? So how do I reallocate the array? Well, I just use realloc. Right? So reallocate S's data array so that it has that much room in it. Right? Now remember here, it's really capacity times size of car. Right? But also remember, size of car is 1. Right? So technically, so you don't actually need the size of car here. But remember, if you're working with some other type that's not car, right, you have to multiply the number of elements here by the size of each element. Right? So reallocate the array. Right? Now remember, if the reallocation is successful, that pointer there is no longer valid. Right? So I need to, so realloc returns a pointer to the newly allocated array or chunk of memory. Right? And before you leave the function, don't forget to set S data so that it now points at the newly allocated chunk of memory. Right? Also remember that realloc copies whatever was in here, right, into the memory that is pointed at by buff. Right? So S data contains all the information it did before I called ensure capacity. Right? now the capacity of the array has changed, right? So now I have to update S capacity as well. Right? So I'm just going to grab this guy here and copy it into here. Right? And so here for assign, right? Before I actually copy the contents of RHS into LHS, right? I'm going to make sure LHS has enough capacity. Right? So I'm just going to call that function there. Right, passing in LHS and passing in. Okay, so we need at least as much room so we need it, the capacity of LHS has to be at least 1 plus the length of the string that's in RHS. Right? So I could write this as length plus 1. Right? You could also write this as RHS capacity. Because you know that the right hand, whatever is in, assuming I've done all my work correctly, right? The string on the right hand side has sufficient capacity to hold the characters of the string. Right, so either one in this case will be fine. Right, so after I've done that, I know that the left hand side, it's still the same string, right? But now it has sufficient capacity to hold what was ever in this string here. Right? So now what do? Well, you just copy the contents of RHS into LHS. Right? So again, you can use any one of the standard string copying functions. Right? So string CPY, memcopy, or sprintf. Right? So string copy, destination. So LHS data, RHS data, like that. Right? String copy copies the null terminator in, so I don't have to worry about the null terminator. Right? I don't have to set the capacity of LHS. Right? Ensure capacity already does it for us. I do, however, have to set the length of LHS. Right? And getting the length of LHS is easy. It's the same length as whatever RHS is. Right? And so there's your assignment function. Right? Assign the contents of that string into this string here. Oh, I have to return something here too, right? So I want to return the left-hand side in this case. And so there's assign. Any questions so far? All right. I guess what's the last function here? Concat. Okay, so concat is also easy at this point. All right, now that I have ensure capacity, concat is also very easy to implement. Okay, so concat, takes the contents of RHS and appends it to the end of LHS. Right. I think it has the same error checking as the previous function. So if RHS is null, LHS remains unchanged. Right? If LHS is null, it returns a null pointer, and that's fine too. Okay, so the exact same error. Oh, so we might as well copy everything. Right. So the first two if statements do some error checking for us. The third one, we want to ensure that the capacity of LHS, right, is not equal to RHS capacity. Right, but rather it is at least equal to that. Right? So concat joins the contents of that onto the end of LHS. Right? So how much room do I need for the concatenated result? I need at least that much room, right, for the original string, plus the characters coming from the right-hand string, plus one more for the null terminator. Right. After I've called ensure, right? Question? No. So you're going to overwrite the null terminator in the left-hand string with the first character of the right-hand string. Yeah. So you don't need both null terminators. Yeah. Right. So after calling ensure capacity, LHS is still unchanged, but it has enough room to hold the concatenated result. Right? Now do the concatenation. So if you want to, you can call memcopy, oh wait, you have to be careful with this one. So what does this say? Concat. Oh yes, okay. So concat, you have to remember that the standard library version of concat cannot concatenate a string onto itself. Right? Here, we would like to be able to concatenate a QString to itself. Right? And so we can't use string concat here or stringcat here. Right? We have to do the concatenation ourselves. Right? So when we do this ourselves, right, you remember you're going to append a string onto the end of possibly the same string. Right? And so here you have to use either memcopy or memmove to do this one. Right? Can you use, yeah, you can use memcopy. Sorry, can you use mem? Yes, you can use memcopy safely in this case. Right? So here I'm going to copy. Right? I want to copy the contents of the right-hand side string onto the end of the left-hand side string. Right? And so where is the end of the left-hand side string? So it's LHS data plus, right? So how long is the left-hand side string? So it's LHS plus length. Right? So LHS data plus the length of LHS, right, takes you to the null terminator at the end of LHS. Right? So that's where I want to start writing into. Right? Where do I want to start writing from? I'd like to start writing from our HS data. Right? How many characters do I want to copy? I would like to copy all of the characters belonging to RHS plus one more. Right? So I'm going to copy RHS length plus 1. Why the plus 1? Because right? So remember the length does not include the null terminator. Right? I know that the null terminator is at the end of RHS's data array because all of our functions ensure that the null terminator is there. Right? So I want to copy all the characters belonging to the right-hand string, right, plus its null terminator. Right? And now I can return, oops, sorry. After I've done that, the length of LHS is equal to the length of LHS plus the length of the right-hand side. Right? And now I can return LHS there. Right? And so there is your concat function. Right? And this one safely concatenates a string onto itself. Okay, almost done. So I'm going to ignore remove range for now. Remove range will remove a substring from a QString. Right? It's not hard to implement. Right? All you need to do is call memmove to shift a bunch of characters from the end of a string, so everything past the substring onto the on top of the substring itself. Right? So here you're just going to look. You're just going to use memmove. Destroy is the function that I want to implement before we leave. Okay, so remember what our initialization functions did, right? They allocated some stuff, right? They allocated some memory. Oops. Like that. Okay. Right. So destroy is going to sort of undo whatever our initialization functions did. Right. So our initialization functions, they allocate the structure, right? And they allocate the structure's data array. Right. So when I destroy a QString, I want to destroy the QString's data array, right? Free its data array, and then free the QString object itself. Right, in that order. Right. So destroying a QString object means freeing the data array belonging to the QString object, right, and then freeing the QString object itself. Like that. Right, in that order. Right. I can't reverse the order. Right. If I free S first, right, S is no longer a valid pointer, which means I can't safely get to its data array. Right. Remember that when you call free, you can only free arrays that have been, or memory that's been dynamically allocated, right? And so whenever I returned a QString object, right, that QString object came from one of our allocation functions, right? And our allocation function always uses malloc to allocate the structure, right? So I can safely free that pointer, right? Our arrays, or the data arrays belonging to our objects, always came from calloc, so I can also free those arrays as well. Right? And so both of these calls to free are safe, right, and should succeed, unless I suppose S is null. But let's see what the header file says. It does nothing if S is null, right? So if S is null, I guess we should put in the test here. So if not S, so do nothing, you can just return like that, right? And there's your destroy function, right? And so this is new if you're coming from 124, right? So from 124, Java, you never care about destroying objects, right? Objects take care, well, the Java virtual machine takes care of destroying objects for you, right? In C, you're responsible for the resources used by your objects, right? When you're done with your objects, you need to return those resources back. And so here, we're going to free any memory that we allocated when creating and using our structures, right? And there's your implementation of a string, right? Which is exactly the same implementation of a list, as a list, right? You can imagine adding extra functions, right? Inserting into the middle of a list, removing from the middle of a list, and so on and so forth, right? But all of the basics are there for you. All right, any questions? Super. We're slightly over time, so I guess we should end things here, and we'll continue our discussion on Thursday. Hopefully that actually works. I know the one in the notebook works.